Alrighty, let's get started. I'll go over the do now. If you got an answer, you can feel free to put it in the chat. Otherwise, I'll work it through for you. Don't worry, I didn't change it up on you. I just gave myself a little bit more room so I can write. You're waiting in line at Chick-fil-A. There's 8 people in front of you. If the total distance between you and the person ready to take your order is 54.0 feet, how many meters are between you and Delicious Destiny? And you'll notice that I gave you a unit equation. 1 meter is equal to 3.28 feet. All right, we're going to see if that is the answer at the end. So keep working if you are almost there. Otherwise, work along with me. So the question that we have to answer is this whole big old paragraph just to say 54 feet is equal to how many meters? This is a U.S. metric conversion. For a problem like this, if it were on an exam, I would give you the unit equation just like I did here for the do now. So we already know 1 meter is equal to 3.28 feet. Now we just have to write our unit factors. The unit factors look like fractions. 1 meter over 3.28 feet. And then you flip it. 3.28 feet over 1 meter. We're trying to get from 54 feet to some number of meters. So which unit factor will I use, A or B? Exactly. If we're trying to get rid of feet, then we need the unit factor with feet on the bottom. Our units cancel. I have to see a question. If we were to write the question as question mark meters equals 54 feet on the test, no, absolutely not. It would not be wrong. It's the same thing. You just wrote it a little bit differently. This is just how my brain works. If yours works in the reverse of that, but we still end up at the same place, then that's all good. So essentially in your calculator, what you're going to do for this one is divide 54 by 3.28. Your calculator will tell you some numbers, but we need to take into account significant figures. And the only measurement from the problem is the 54 feet. That has 3 significant figures because that decimal point tells me that the 0 is measured. So we need to round our answer to 3 significant figures, which would be 16.5, and of course our units. So the answer should be 16.5 meters. So if you were to give me that, show me your work, and give me this answer, you would get full credit. If you, let's say you use the wrong unit factor, you would still get a decent amount of credit. So when you show your work for the chapter check-ins or for the exam, it allows me to give you more credit than just right or wrong, but I can give you partial credit and I can see where you may have gone astray. So on the exam, this is the kind of thing I want to see. I want to see you write out the question, your unit equation, the unit factor. I should be able to follow it without, I shouldn't need a map or a legend to be able to figure out how you solve the problem. So how do we feel about this? How did that problem feel? Meh, good, confident? For the exam, so I see a question, are we doing our work on the computer? So no. For the exam, what you're going to do is, as you're taking the exam, just like you would do for a chapter check-in or while you're doing your mastering chemistry homework, you're going to write out the math questions, which is mostly all math. You're going to write out your work just like you would. Oh, I see you, Lydia. It's fine. It's fine. I see you coming in and out of the room. um, so you would write out your answers, and then you're going to have to upload your work just like you would the chapter check-in. So after you finish the exam in Respondus Lockdown browser, you close out of that, go to Blackboard and Firefox or Chrome or whatever you use, and upload your answer, your work, as a PDF to the assignment that I've posted in the Exam 1 folder. So you can't see the Exam 1 folder yet because it's not available yet. But in the folder, there are, let me write it down. So you're going to see a folder in the course content labeled Exam 1. You're going to see Exam 1, right? You're also going to see the equation sheet that you'll need to print before you start the exam. The exam is available starting tomorrow, which is Wednesday at 8 a.m., and it will be available until the end of Friday, so 11:59 p.m. Eastern Time. Once you sit down to take the exam, you have to take it all at once. So find a time where you can sit down for an hour or so and do the exam. You will need to print out the equation sheet. The pretest is due at the same by the same time. All right, hold on, y'all. Y'all give me all the questions, okay? So pretest, it's not a real test. It's just to try out the Respondus Lockdown browser. So you have to download the browser and then use the browser to navigate to Blackboard and take the practice test to make sure that your computer is compatible with Respondus Lockdown. It just asks you about your major, if you have to take more chemistry, and what time slot of the ones that I have available for office hours works best for you. So it's not a real test. It's like 3 points, and it's the 3 easiest points you will probably ever earn in this class. So set it up, and then you'll be good to go there. Okay. If you do not have a printer, so let me make sure. So we answered, when is the exam? The practice test is available for this until the exam 1 is unavailable. So the exam will come online tomorrow morning, and it will be unavailable Friday midnight. So you have I guess it's technically Saturday midnight. So you have to finish the exam by the end of Friday. You can write out so the equation sheet is not that long. So if you need to write it down and use that, that's fine too, if you don't have a printer. What I'm telling you to print out is the equation sheet, not the exam. You cannot print the exam, but you need the equation sheet to do the exam. If your computer is not compatible, then you need to, if you're on campus, you can borrow a computer from the library, Or if you're not on campus, then if you have a friend or a family member or somebody else with a computer that is compatible, see if you can borrow theirs. But you have to do the exam through Respondus. Okay. I think I saw a question about how many questions. We're not going to tell you how many questions are on the exam. So the equation sheet will be different from exam to exam, but the final exam, you'll have an equation sheet that's pretty much all of the equation sheets that we had together. So no, it's not going to be the same thing because the exams during the semester, while they're cumulative, I'm not going to be asking you about percentages necessarily or metric conversions on exam 2. So you don't need that stuff. So it will be a different equation sheet every time that's relevant to the chapters that you're taking an exam on. Did I miss any questions? Is anybody? So, where can you download it? Yeah, so you're going to have to be able to complete the exam in 2 hours. So here's the deal. If I put that on there, then if you have any issues with your internet connectivity during the time of the exam, you won't be able to log back in and take it. So what I want you to do is 2 hours is a very generous amount of time. You should be able to complete the exam and upload your work to Blackboard in 2 hours. So the equation sheet is not that long, so you don't have to. If you need to write it out, you can just look at Blackboard and write it out on a piece of paper, and that's fine. If you're near the school, you can print it out there. That's right. Otherwise, the libraries and stuff are closed. To download Respondus, there's on Blackboard, you'll see a Respondus quick start guide, and I posted way back the link for where you can download it. You can search NCAT Respondus lockdown in Google, and it will give you'll get the link for where you can download it. Otherwise, you can dig through the announcements, and there's a link in there, along with the start guide and the course content. I'm not going to tell you how many questions are on the exam, but it is reasonable. It's not as long as the exam review. The exam is out of 115 points, so there's some extra credit questions. So you can get some wrong and still get 100 on the exam. So that's not telling you how many questions, but it gives you an idea of, if there's a couple of questions where you're like, I don't know about that, there's some wiggle room for you there. Any other logistical questions about the exam? Okay. All right, so now what I'm going to do is I'm going to put up a poll. Nope, not that one. Because I want to know whether or not you want to do exam review first and then chapter 3, or chapter 3 then exam review. So I'll do a poll just so that it's easier to keep account. Okay, so there's the poll. Choose which one you want to do first. If we end up doing exam review first, then that means that it's going to be on you to do more of the work for chapter 3. And I see another question, where's the sheet that you print out? So I've already posted the equation sheet in the exam 1 review folder. It will also be posted in the exam 1 folder when it becomes available. So you can't see the exam yet. It will become available tomorrow morning. But I will post an announcement that lets you know where to find the exam and everything else. So if you want to print out the sheet ahead of time, you can print out the equation sheet that's in the exam 1 review folder. It will be the same exact one. Oh, we still have 5 more people. Please vote because it is so close. Still need some more votes because at this point, if all the non-response people voted for chapter 3, okay. Now we're at a point where even if the no response folks voted, exam review would still take it. So this was closer than the other class. So we will do exam review first, and then we will get to chapter 3. So let me skip ahead. Give me 1 second. So we'll do the review first, and then we'll go back and do chapter 3. Alrighty. Now I ordered this so that the questions that we're going to start with for the exam review are ones that we have not directly addressed in class. So we haven't done an exact problem like it before. Then we'll get to some of the ones that we've done already. So the do now was a practice for conversions. It was the US metric conversion, but it's very similar to the metric conversion. This question is a density question. So if you haven't had a chance to do the exam review, I want you to take a minute. Okay. I want you to take a minute, read the question, and I recommend drawing it out and taking a stab at the answer. So I will give you 3 minutes to read it and put in an answer, or at least put one down in your notebook or in your brain. If you have an answer, you can put it in the chat. Otherwise, let me know. Are you like, don't get the question, need help, or do you just need more time? Okay, so we're getting a lot of people saying that need a little help, because we did not cover this exact question type in class. So there's a tall glass cylinder that contains water floating on liquid mercury, and the density for each of those liquids is listed. A piece of metal is resting on the bottom of the cylinder. Which of the following choices could represent the density of the piece of metal? So this is a concept question. There's no math involved. It's a conceptual thing. Whenever I have a problem like that, I like to draw it out. So there's my glass cylinder. We have some water. And its density. We also have some mercury. And there's its density. I'll try to fill in the water a little bit more. The water is floating on top of the mercury because it's less dense. So we're going from the least dense to the most dense. Does everybody understand that part so far? Now we have to add in our metal piece. That metal piece is resting on the bottom of the cylinder. So if in our cylinder we have the least dense substance on the top and the most dense substance on the bottom, the metal piece, is that going to be more dense than mercury or less dense than mercury? It's going to be more dense, right? Since we know that the density of the mercury is 13.6, you have to choose one of these options that is greater than 13.6. So which option is that? It's D. So now let's test your understanding. Let's switch up the problem a little bit. What if I have a metal piece that is floating on top of the water? Which one of the four options would it be? Yeah, it would be A, because it has to be less dense than the water. And the only option would be 0.697. If I had something that was sitting on top of the mercury, that means that the density would have to be somewhere between the 1 and the 13.6. So that would be either of those options, okay? So now how do we feel about this question? If you have a question, go for it. Oh, I wouldn't do that to you. There would be another option here that would say B and C. Okay? Not going to be that mean. You're welcome. That would be awful. That would be absolutely awful. I hope nobody has done that to you. Well, you should have said both. Like, no, it should be an option. Okay. So that's the graduated cylinder question with density. You will see something like this on the exam. So make sure that you understand it. And the exam review answer key has already been posted. So all this that we're going over, the answer key has it written down as well, but we're obviously not, I can't go into the same detail as I do when we're going over it. Let's move on. This is a specific heat question. I will give you the equation for a specific heat. That's what you will see on the equation sheet. It will not have an explanation of what the different variables are. You need to know that. So I will give you 3 minutes to set up the problem and give it a try. You can put your answer in the chat if you have one. Otherwise, say help. So 3 minutes, and then we'll get going again. And we've got some answers already, and we got some help. So here's some help. I'll define these for you. So C is the specific heat. Q is the amount of heat that is gained or lost. M is your mass of the sample. And delta T is your change in temperature, which is always equal to the final temperature minus the initial temperature. It looks like everyone that put in an answer is pretty close. So the only issue that I would have is units. So let's go through and do it. We're solving for specific heat, so we don't have to do any rearranging. The heat gained or lost, well, the amount of heat gained by the metal is 125 joules. The mass of the sample said it's 12.6 grams. And our change in temperature is going to be the final temperature. So it was heated to 32 degrees Celsius. And our initial temperature is 25. Remember that your change in temperature always has to be Celsius or Kelvin. Is there a question? Okay. So let's set this up. When you put that into your calculator, it's going to tell you a bunch of numbers. But what we need to do is figure out significant figures. And in this case, everything has 3 significant figures. So that's what we should report our answer with. Now the units. We've got joules divided by grams degrees Celsius. Can't cancel any of those things out. So that's what your units need to be. Questions about that? Yes. Yeah, in this class, we're only dealing with joules, but you can have other energy units like calories or something like that. But the units are always going to be joules per gram degrees Celsius. What it's dependent on is what your heat is in. So it could be joules or calories. I think somebody has their mic on. Okay. So no, I'm going to give you more than half credit. Generally speaking, depending on the amount of the problem, I'll take off half a point to a point if you don't have the correct units. If you did all the calculations right and everything else, that's the bulk of the work. I thought I saw another hand or a question. Yes. What's your question? So let me ask you this. When you put it into the calculator, what you need to do is that divided by, and then you have to use parentheses so that the subtraction gets done um, in the correct order of operations for this. So if you're putting it into the calculator, you need to use parentheses. Otherwise, you can just calculate this as 7, and then you can put into your calculator 125 divided by 12.6 times 7. Yeah. So I got distracted by the chat. There should be parentheses for that too. So parentheses are your friends. Other questions? Thank you for answering. Alrighty. Then let's move on. And just as a reminder, as a class, we chose to do exam review first. So we may not get through all of chapter 3 because of how long we're taking with exam review. There's no chapter check-in for chapter 3 this week. I just want you to focus on the exam and then doing the chapter 3 mastering chemistry homework and quiz. So your attendance for this week will just be doing those things. So we're not going to worry about the check-in. I think that would just be too much. So this is a heat versus temperature question. I always get questions on this. We did not do one specifically like this in class. So let's set it up together and then you can go for it. So we've got 2 beakers. One that has 50 milliliters of 40-degree Fahrenheit water and one containing 50 milliliters of 40-degree Celsius water. Which beaker contains more heat? What you have to know before you can do anything is the difference between heat and temperature. Heat, we're talking about the total energy of the system. And in our problem, that would be the beaker of water. The temperature is a reflection of the average kinetic energy that each particle has. In our case, that would be one molecule of water. So the beaker of water versus the molecule of water. Okay, that's the difference between heat and temperature. What this question is asking is, if I've got these two systems, which we can draw out, we've got two beakers, which are their own systems. They each have the same amount of water. Despite what they look like, they have the same amount of water. But they have different temperatures. And you have to figure out which one has more heat. The other key to this question is looking at the temperatures that are there. One temperature is in Fahrenheit, the other temperature is in Celsius. So can you directly compare these two? That's right, you can't directly compare this. So what can you do so that you can compare them? You have to convert. So you can either convert Fahrenheit to Celsius or Celsius to Fahrenheit. Doesn't matter which one you do, but you need to do that. When I did the problem for the answer key, I converted Fahrenheit to Celsius. Either way, as long as they are both the same units. So now I want you to take a couple of minutes and try to figure out the answer to the question, which beaker has more heat? I will give you 2 minutes, do your conversion, and then take a stab at which one. We'll call the one with 40-degree Fahrenheit water beaker A, and 40-degree Celsius water beaker B. Y'all might not even need time. So there are definitely, I'll give you at least a minute because there are some people who are going to need a little bit of time to answer the question. So I'll give just one more minute. Alrighty. So if we were to convert from degrees Fahrenheit to degrees Celsius, we just have to plug and chug. So we've got 40 degrees Fahrenheit minus 32. You're going to want to do that math first, and that's 8, right? Then you multiply by 100 degrees, divide by 180, and when you do that, you should get 4.4 degrees Celsius. We're not going to worry about sig figs because that's not what the question is asking. Now that we've got equal footing in terms of the temperature scale, we can compare them. So 50 milliliters of water in each. Beaker A has a much colder temperature than beaker B. So beaker B has more heat. There will be a question like this on the exam. Not the exact same numbers. You won't have to do any math outside of converting a temperature. but you need to understand the concept. So are we good on this question? Good. Moving on. Now we're going to go back and do some adding and subtracting and that sort of stuff with sig figs. So there's 3 measurements here. They're volume measurements. Add them up and report your answer using the correct number of significant figures. Now for this type of question, where it's directly testing your knowledge of significant figures, if you do not put the correct number of significant figures, it is wrong. On a question like the specific heat question, while sig figs matter, I'll only take off a point or so. If you have the right numerical answer, you just didn't put, now if you just took all the numbers from your calculator and wrote it down, you're going to get a couple points off. But if you put 3 sig figs instead of 2, or 2 instead of 3, I'll just take a point off. So just want to clarify that there. Even if you don't do this by hand, I always recommend that you line everything up and draw a line to know where you're supposed to round. For adding and subtracting, what you care about is the number of decimal places. So we can report 2 decimal places here. Your calculator is going to tell you this answer. We need to round that 2. With sig figs, this becomes 21.73 milliliters. Don't forget your units. If you forget your units, you will lose half a point. Units are important. So in this case, if you didn't have this full answer, it would be wrong. This is the only question type where I'm that much of a stickler. So are we clear on that? Okay. I try to be fair. I try to tell y'all everything up front. Not trying to be mean, but we have to have some kind of order. So let's do a rounding question. You have this obscene number of meters. You need to round it to 2 significant figures and write your answer in scientific notation. Again, this is a type of question where if you don't have the correct number of significant figures, it will be wrong because I'm directly testing your ability to round with significant figures. Remember, you're supposed to write your answer in scientific notation. So if this were a multiple choice question, I could have some answers that are not in scientific notation too. Yeah. So let's go through this one. We've got to do 2 sig figs. We'll do that first. That means we're rounding the 8. That 8's going to go up to a 9 because the digit next to it is a 9. But 19 is very different from 189,000 something. So we've got to add some placeholder zeros. For each of the digits that we dropped off, we have to add a 0. So that's with 2 significant figures. Correct, but not in scientific notation. Scientific notation, we're going to take that implied decimal point and move it 1, 2, 3, 4, 5 spaces over to make our coefficient. And our exponent is positive because we've got a number that's bigger than 1. And finally, units. So this should be your final answer. So on the exam, do not forget your units, because losing a half a point for almost every question adds up. Seems like most of you got that once I reminded you about the scientific notation. So I'm going to guess that we're good here. Are we good? Great. Now we're going to switch gears and go to writing unit equations. Okay. Oh, so I have a question about something a couple of slides ago. So, yes, 21.73 milliliters has 4 significant figures. But when we're adding and subtracting, what we care about is the number of decimal places. And so the fewest decimal places that we have is 2 decimal places. So our answer also has to have 2 decimal places. All right. You're welcome. When you're working with multiplying and dividing, then you care about the number of significant figures, and the measurement with the fewest significant figures tells you how many sig figs to report in your answer. So if we were doing 5.0 times 7.00, you could only report 35 because there's 2 sig figs here and 3 sig figs here. So that's the difference, multiplying and dividing. Alrighty, let's jump back ahead. What if you're doing both? Then you end up you look at the problem for the measurements, just like we do with the specific heat one, where you look at the different measurements in the initial information in the problem and figure out which measurement has the fewest significant figures. And then you report your answer using that number. So if you're doing more than just one operation, you're mixing, adding, and multiplication or something like that, then you just go with the fewest number of sig figs. All right. So now we have one where we've got to complete the unit equation for the following metric equivalents. You're going to have this table available to you. It's part of the equation sheet. So you do not need to memorize it. You just need to know how to use it. So do these two problems, and then we'll go over it. Okay, so we've got several people chiming in with their answers. So let's get started. You know my preference is scientific notation, but you can report it either way, the regular ordinary number or scientific notation, whichever one makes the most sense to you. This is how I do it because usually when you're setting up a unit equation, you're going to be doing a conversion of some kind, and the scientific notation is usually more helpful. But that said, it's up to you, scientific notation or the decimal number. A liter is bigger than a deciliter. So we're going from a big unit to a small unit. You can tell that because a liter is here, the base unit. And we're going one below that to deci. Whenever you're going from a big unit to a small unit, you're going to, if you're using scientific notation, you're going to have a positive exponent. Your number is going to be bigger than 1 if you're doing a decimal number. So 1 liter is equal to, you take the number here, 1 times 10 to the 1, and we want it to be positive. And that's the same thing as saying 10 deciliters. So 1 liter is equal to 1 times 10 to the 1 deciliters, which is the same as 10 deciliters. For the second question, it's a very similar deal. We're going from big to small because a second is up here, centi is down here. So if you're using scientific notation, you're going to have a positive exponent again, which is the same as saying 100 centiseconds. What if I flipped it? One centisecond is equal to how many seconds? Then what would my answer be? Exactly. Because this time you're going from small to big. So know how to do those. You will have a couple of those on the exam where you just have to fill in the unit equation. But you'll also need to know how to do this in the context of a problem where you're given one measurement and you need to convert it to another. So for those of you who participated, it seemed like y'all got it for the most part. So unless someone stops me, we're going to move on. I wanted to give you, yes, Patrick. Scientific notation is fine. I just write both just because I know some people have a preference for one or the other. So if you wrote either one of those, you would be 100% correct and you get full credit. You're welcome. The last question I wanted to go over as review is a sample extra credit question. Now, I typically have two flavors of extra credit. One will be easier, where it's just like a regular problem type that I would expect most of you to be able to do. It'll help you recover some points if there was a particular topic that you didn't vibe with. And you're like, oh, okay, but I get this over here. Then I have a slightly more difficult question where they're all concepts that we've covered. There's nothing new per se, but it looks new. So you have to connect the dots from class to be able to do the question. And those extra credit problems are going to be worth more because you have to do more and you have to show more understanding and a deeper understanding of what we've done. So I wanted to give you this example so that you get an idea of the type of extra credit question that you might see on the exam. I will give you 5 minutes to read through this and give it a shot. At the very least, try to come up with a plan or say what the question is, but try to get somewhere with it. Anything that you show me that's correct, you get partial credit for, even for extra credit. So don't just leave it blank. If you don't have an actual answer, at least put something down. Write out what the question is or what the plan would be to figure it out. Don't just put that on your work that you upload, but put it in the Blackboard exam. So let's practice that now. Take 5 minutes, so I have 3:10. At 3:15, I'll start going over the problem. There we go. Alrighty. 7 grams of carbs per serving. And we have something that looks suspiciously like a unit equation. 1 gram of carbs gives you 9 capital C calories. So here's our plan. First thing is we have to figure out how many calories we're getting from the carbohydrates. So we have to go from the grams of carbs to calories. Then we can figure out the percent of carbs or calories from carbs. We know that a percentage is part over a whole times 100%. So we're looking for the calories from the carbs over the total calories times 100%. So if you gave this to me without doing a lick of math, you would get a few points. Not all the points, probably not even half. But you'd probably get somewhere in the ballpark of a third of the points. So don't just leave it completely blank. Give me something. Don't just repeat what's in the question, but add to it. So if you can give me the question that's boiled down, give me a plan, label something as a unit equation or a unit factor, something like that, so that you can at least get a point or two, okay? Now let's execute the plan. We've got 7 grams of carbs. And we're just going to write out our unit factor on the fly. We're not going to write out both of them. I've got grams of carbs that I need to get rid of. So that has to go on the bottom. And I fill it in from the unit equation. On the top, we're going to have calories. When you multiply that out, if you remember your times tables, you shouldn't need a calculator. You get 63 calories. But that's only the first part of the plan. We know how many calories we're getting from carbohydrates. Now we've got to figure out the percentage. $63 calories over the total 140 calories times 100%. That should give you 45% of your calories are from carbohydrates. If you just put 45%, that'd be fine. So good for y'all who got it right. If you didn't, that's okay. Just show me something, okay? Yeah. So this is combining a couple of different concepts. We haven't done anything with nutrition in this class, but recognizing that this 1 gram of carbs is equal to 9 calories is a unit equation shows me that you understand the idea of doing conversions. And no matter what the units are, whether it's metric, US, whether it's about nutrition, whatever, you can do a conversion. And then you can combine that concept with percentages. We've never really combined those two things before, but you can. So that's why this is kind of a step above the normal exam questions that you will see. So is everybody good on that one? What's your question? I thought we had a hand raised. Okay. So that, I believe, is it for exam review. Now we've got to roll back around and do the actual chapter 3. Before we get to that, ain't no shade, I'm just curious so that I can give you what you need. How many of us were able to watch the chapter 3 lecture video and take notes? Just by a show of hands, or you can say me. If you did it, it's all good. I understand. You've got more than just this class, and you have an exam. So if you have not yet gotten to it, I understand. If I were a student in your position and I knew I had an exam, I would be focused on the prerequisite science skills in chapter 2, and then chapter 3 would have to wait till after the exam. So I understand. So here's what we're going to do. We're going to take a 10-minute break. Chapter 3 is not on exam 1. It's on exam 2, which is coming up much sooner than you think. So let's take a 10-minute break. Then when we come back, we'll treat this more as an overview of chapter 3. You will still need to watch the lecture and take notes, and it will help you with your homework. But there is no chapter 3 check-in this week. You've got an exam, you've got to do mastering chemistry, the homework, and the quiz for chapter 3. I don't want to add a chapter check-in to that. So focus on those things, make sure you get them done, and then we'll pick up with doing the chapter check-ins for chapter 4 next week. With that said, we are going to take a break. I have 3:23. So we'll break till 3:33. Good 10 minutes. Go stretch, and then we'll get back to it. Let's get back to it, guys. Break time over. We've got to go over chapter 3. And I realize that many of you have not looked at the chapter 3 lecture. Again, I get it. I'm not offended. I understand. I'm not your only class, and some of y'all work and have other stuff, other exams to study for, or my exam to study for. So there's no shade, but it helps me to know what the audience is so that it can either be we can do questions, or if I need to kind of go through it and it's more of an overview of what you should expect from the chapter. So here I do have some questions put in to answer, but what we'll do is we'll use those as kind of a way for you to understand the types of questions that you'll be asked, so that when it comes time for homework and exam number 2, you won't be surprised. Let's get started. So I like to fill in the table, and I like tables in general. We're talking about the states of matter, solids, liquids, and gases. I'm sure that you have heard of these before. This is not the first time. But we're going to put some more vocabulary words to describe some of the different properties of solids, liquids, and gases. So below you'll see a word bank, and these are the same types of words that you'll see in your textbook and in your homework with Mastering Chemistry. This table is pulled directly from the table that's in the lecture. So you can use this as a practice for yourself to be able to fill this in. I'm going to go ahead and fill it in one by one and kind of talk about the difference between the terms and what each property is. The first property that we're going to talk about is shape. The words that we use to describe shape are fixed and variable. So is the shape fixed? Is it just, think about a rock like a solid. You're not going to change the form of that rock. It is whatever shape it is, and that's just it. But a liquid, maybe the shape can change some, so that would be variable. So for solids, the shape is fixed. For a liquid, if you can think about, you pour a cup of water, you take that same water and put it into a bigger cup or a smaller cup, it's going to take the shape of whatever the container is. So its shape is variable. Now, gases may be something that you don't know a lot about, because you typically don't talk a lot about gases in school before you get to college. The gases, too, have a variable shape. Volume, we're talking about how much space something takes up. For a solid, that's going to be fixed. You can't compress it or anything. The volume is what the volume is. The same thing for a liquid. Even though the shape is variable, if you have 50 milliliters of water, it doesn't matter what container it's in, it's still the same volume. There's nothing that you can do that's going to change the volume of the water, except drink it, I guess, right? But then you have a different volume. Gases, on the other hand, they will take up whatever volume they're put in. So you can take all the gas from one room and compress it down, squish it down into a smaller volume, or you can open it up and make the room bigger. All the gas, all the air that's in the room is going to change its shape and its volume based on the container. I alluded to, so I guess for shape and for volume, we use fixed versus variable. And when I ask you, is that clear, it's not necessarily, is the concept clear, but do you understand what you're being asked to do and what you're going to be asked to know when it comes time for homework and exams? So are we good so far in terms of the kind of reasoning you'll need to do for the different properties. Okay. So this is a lot more of me talking than I like. I don't like to just lecture on and on and on and just give you death by PowerPoint. One more time. Okay. So when we're talking about shape and volume, we're talking about whether or not we can change the shape or the volume based on the container that something's in. If you put a rock into a glass container or you put the rock on the plate, the shape is going to be the same, the volume is going to be the same. For liquid, if you have a cup of water, you pour it out onto a plate, well, the shape of the water is going to be different. But the amount of water, the volume, say it's 50 milliliters, is going to be the same, no matter where it is, whether it's in a cup or on a plate. Gases, their shape and their volume are variable. And that's just due to the properties of gases that we'll talk about a little bit here, but we'll get to more at the end of the course when we're talking about gases in Chapter 10. So take my word for it when I tell you that the shape and volume of a gas is variable, and it depends on the shape and volume of the container that it's in. Now we need to talk about compressibility and energy. Compressibility means, okay, good. Can I push down on it to change its shape or volume? For a solid and a liquid, it's not significant. And those are the words that you're going to see associated with it for compressibility. I'm just going to abbreviate it NS here for liquids. For gases, however, you can compress a gas. If you have ever used PAM or any kind of cooking spray, or if you've used sunscreen, in the can, anything like that, if you like Ready Whip, we're talking about things that are compressed and under pressure. There are gases, propellants in those cans that help to express that oil or whatever it is out of the can and onto your pan or something like that. Gases are significantly compressible. Finally, we're going to talk about kinetic energy. So this is talking about the kinetic energy theory, which we don't have time to talk about exactly what that is, but I do talk about it in the lecture on YouTube. So make sure that you check that out. For now, I'm just going to tell you that the energy is relative, and the words that we're going to use to describe it are high, medium, and low. The particles in a solid have low energy. They're not really moving that much. In a liquid, it's kind of medium, middle of the road. And a gas is high. Those particles are spaced very far apart. They're moving around very quickly. So for this last row, you're going to need some more information, and that is found in the lecture. You're not just going to have to fill in this table. You're going to have to be able to answer questions. Say I said, okay, which state of matter has a shape that is fixed and is not significantly compressible? You'd have to tell me a solid. So that's how you need to be able to process this information. Does that make sense? I am getting attacked by an invisible mosquito, and it is driving me insane. I'm trying to keep it together for y'all. We got less than an hour. We got 45 minutes, and I am under siege right now by this mosquito in my garage. So help me. If you hear a random slap, That's what it is. I'm going for blood too, mosquito. Hear me now. But it is in my house, coming for me in my life. I know I am sweet as pie, but please leave me alone, mosquito. Okay. I'm just being honest with y'all. I have problems too during lecture. You just don't know it. Okay. The next thing that we covered in the lecture was changes of state. So I'm not going to go through this whole slide. You should, by the end of the lecture video, you should be able to fill this in with the different words that I give you, the vocabulary to describe going from a solid to a liquid, liquid to a gas. If you think about an example, which water is always the best, you can probably already fill in some of these words. So if ice becomes water, it has melted. So you know the word melt. If you're trying to make some ice, you're about to have a party, which you shouldn't be having because of COVID, you're going to freeze the water to make ice. So those terms you're going to need to know. You also already know boil. You may not think about the word condense, but that is the opposite, to take the vapor and then cool it down to make the liquid. And one that you may not know, one pair, is sublimation and deposition. This only happens in special cases where you can go directly from a solid to a gas and vice versa. The best example I can give you is dry ice. That is solid CO2 or carbon dioxide. If you've ever seen one of those movies where it's some mad scientist somewhere, or it's in a commercial or something, and there's all these beakers and flasks on this table, and they're different colors, and you see all the steam coming out, that's just a Hollywood trick. It's water with some dye, and it's got some dry ice in it. You might see some bubbles in it. Oh man, that's chemistry. I mean, it kind of is, but it's really just a phase change. Dry ice is the solid, and at room temperature, it will simply become a gas. So you're watching the solid become carbon dioxide gas. That's an example of sublimation. You can also reduce the temperature of carbon dioxide, and it will just skip over the liquid stage and become a solid under certain conditions. So that's a pair that you may not know. Make sure you understand all of these and that you can use them intelligently. So this would be right for matching, fill in the blank, those kinds of questions. So are we clear on that? The physical changes of state and what you'll need to know. All right. I said I wasn't going to fill in the chart, and look at what I did. I can't help it. I can't help it. From there, we talked about the classification of matter. So matter is anything that takes up space. It's all the things. You can touch it. You can breathe it. It takes up space. Air, the desk, the chair, your computer, all those things are matter. It's a pretty big category. So we've got some terms to break things down even further. The next category would be mixtures and pure substances. Mixtures are not chemically combined. So an example of a mixture would be salt water, Kool-Aid, or your favorite beverage that you can take a powder and add it to a water, maybe add some sugar. That is a mixture. It doesn't have to be a liquid. It could be something like brass. Brass is a combination of copper and zinc metal. So that is a mixture. You can break mixtures down into heterogeneous or homogeneous. And that just means, can you see the different layers? Can you see the different components? Or does it all look like one thing? Heterogeneous, you can see the different components. The example here is oil and water. That's what's depicted. So if you've ever made a salad dressing, when you put the oil and the vinegar together at first, you see the oil floating on top of the vinegar. You have to shake it in order to emulsify the two and get the fat to dissolve slightly into the vinegar. That is a heterogeneous mixture. So if you think of a salad dressing or something like that, that will help you. Homogeneous, you can't tell that it's a mixture. If I put a glass of water straight from the ocean and water from the tap, we'll say purified water, so it's just plain old water, you wouldn't be able to tell the difference really unless you tasted it. That's a homogeneous mixture. Can't see the components. So we just covered matter, mixtures, and the two subtypes of mixtures. You still with me? Okay. I do not like lecturing in this platform, so I'm going to try not to say it again, but I do not like it because it's just a lot of me talking and y'all sitting there, and that bugs me. Everybody needs to be doing some work, but I get it. So now let's talk about pure substances. Pure substances, we're talking about anything that has a fixed and definite composition. So if you think about the mixtures like salt water or Kool-Aid, if you make Gatorade with the powder, you can add as much or as little powder or salt as you want, and it's still going to be salt water, it's still going to be Kool-Aid or whatever. It's not a definite composition. It is up to you. With a pure substance, there's a fixed and definite composition. So if you have water, which is an example of a compound, that's H2O. If you have any other combination, it's something else. Let's say that you added another oxygen to make H2O2. That's hydrogen peroxide. Those are not the same. Water is H2O. Anything outside of that, you don't have water anymore. That's an example of a pure substance. Water is a compound because it's got more than one element that you can't physically separate. So a compound, you need to use chemistry to break apart the hydrogen and the oxygen. Then you get elements. The elements are what you see on the periodic table. And we'll talk a little bit about the periodic table in this chapter, but we'll really start talking about it in chapter 4 and chapter 5, when we're building up the model of the atom and how the periodic table came to be what it is today. So that's the crash course in classifying matter. You'll need to know all of these terms, know what they mean, and be able to classify matter as a mixture or a substance or pure substance, tell the difference between heterogeneous versus homogeneous mixture, compounds versus elements, that kind of deal. So again, fill in the blank, multiple choice. Chapter 3 is really reasoning and understanding terms. We clear on classification of matter? Good. So I have some practice here. We can't practice it, but I'll go through a couple of them so that you can see um, how I expect you to be able to do this. I see a question, a technical question, so y'all can help this person out. How do you fix their screen connection? If your Wi-Fi is being funky, if you have the option to hardwire, like put an Ethernet cord into your computer, do that because that is more stable. Otherwise, if your Wi-Fi is weird, if a lot of people are home on the internet watching Netflix, then it's going to be a struggle. So classifying matter. I've got 5 different examples here. I'm not going to go through all of them, but I'm just going to go through a couple of them. Is there problems with my audio too? Okay. Let me know. You scared me. All right. Alrighty. So I'll do number 1 and number 2 just to give you an idea of the type of thing you'll need to be able to do. So sodium metal, you will need to recognize that as an element. You'll have a periodic table, and all of the names of the elements are on the periodic table, the one that I'm going to give you to use for exams. So you should recognize that that is an element. You should also know that elements fall under the category of pure substance. Sodium chloride is also known as table salt. But what you can recognize here is that there are 2 kind of element names put together. So that clues you in that you have a compound, which is again under the same heading of pure substance. On your own time, if you want to go back to this lecture, you can try to do 3 through 5. We talked about salt water and brass. That can be a refresher. But the piece of metal and water, you can do that one because that's a fresh example. So try those after you've had a chance to look at the lecture, and then test yourself before you start doing all the homework. Are we clear on how you're going to have to use all this terminology to be able to classify things? The next big topic is metals versus nonmetals. And as I said, I like charts. This chart summarizes the different properties, physical state, appearance, density, all those kinds of things. And it spells it out for metals and nonmetals. You will need to be able to compare the two so that if I give you a description, I said something is shiny and a good conductor of heat, you should be able to, in your brain, say, okay, shiny, that's metallic luster, okay, and it's a good conductor of heat, that's probably a metal. There's another category that is not mentioned here, but I do talk about it in the video, and that's semi-metals. They exhibit a combination of characteristics that's a mixture of metals and nonmetals. So there is no generality that we can make for semi-metals. you will need to know that they exist and that that's what they are. They exhibit a mixture of properties. So knowing this table and being able to compare and contrast, being able to guess, okay, if it has these set of properties, it's probably a metal or it's probably a non-metal. That's what you need to know there. You'll also need to know, in terms of the periodic table, most of the periodic table consists of metals. So the purple, all of the elements that are purple are metals. The green, those are the semi-metals, and the yellow is the non-metals. Metals are most. Then you have this kind of a diagonal line for the semi-metals. And the far right is non-metals. So if I told you, if I had a periodic table, or if I told you that I have titanium and I want you to predict whether or not it's metal, non-metal, or semi-metal, based on its position, you should be able to tell me that it's a metal. Does that make sense? So metals, non-metals, semi-metals, where they are, and characteristics. The one other thing for the periodic table that you'll need to know now is that it's arranged by increasing atomic number. So the little number in the top left corner, that's the atomic number. It increases as you go from left to right and as you go down. And again, this is just the first introduction to the periodic table. We will be revisiting it in Chapter 5 in much more detail. I do not require you to memorize the periodic table. You may need to memorize it if you have to take 106 and 107 or any other chemistry courses after that. But for this course, you do not need to memorize it. The last thing that I wanted to touch on was chemical formulas. And this is something that, oh no, we have one more topic after this. So chemical formulas and then one more topic. But chemical formulas seem trickier than they really are. The chemical formula is kind of like the recipe. So if you have a brownie, you know that there's flour, and then there's maybe an egg, some chocolate, there's the breakdown of all the things that's in it and the measurements. Maybe it's a couple of cups of flour, a teaspoon or two of vanilla, what have you. The chemical formula is the same thing for a compound or a molecule. It tells you the makeup of each molecule based on how many atoms of each element. So when it comes to looking at a chemical formula, you need to be able to state the composition of a molecule. And that's just saying what elements are in it and how many of each element do you have. Letter A is a little bit more complex. So I want to talk about that a little bit just to introduce it. If I were going to count how many carbons there are, which C is carbon, I would look at the molecule, and every time I see a C, I would count it. And if there's a subscript, like there is here, that tells me how many carbons. So I've got 3 carbons just from this C3 here. But I also see carbon here, and it's in parentheses. Outside of the parentheses, I see another number. This is just like in math. If I had 3 on the outside and then 1 plus 1 plus 1, you would take that 3 and multiply it by everything to get 3 plus 3 plus 3. Same way here. You would get 3 carbons, oxygen, oxygen, hydrogen. So that's the same thing as this. It may not 100% make sense to you now. You may need to watch the video again. But that concept of counting the atoms and making sure to count the parentheses, the things in parentheses properly, is usually a place where students mess up. So think about it like you would math. And if you have to, write it out like I just did. So if we're going to continue to count the carbon atoms, we've got 3 here, and then we have another 3 here, for a total of 6 carbon atoms. What I want you to do is tell me how many hydrogens there are. So hydrogen is H. Good. We've got the 4 plus the 1, and then we've got another 3 here from the parentheses, and that gives you 8. That's as tricky as it gets. So you can go through and write the composition of a molecule. You write the number of each atom. So to complete this one, you would have to do the number of oxygens as well. And that would be the composition of the molecule. 6 carbon atoms, 8 hydrogen atoms, 7 oxygen atoms. You also need to be able to go in reverse. So if I tell you the composition of a molecule, you should be able to write that as a chemical formula. That's what number 2 is. So there's lysine, which is an amino acid. Amino acids make up all the proteins in your body. Lysine is just one of many. It contains 6 carbons, 14 hydrogens, 2 nitrogens, and 2 oxygen atoms. The way you would write that is capital C for the carbon, and these you would get from the periodic table. As you do these problems and as we work more with the elements, you'll start to learn them organically. The number of atoms goes down below. That's called a subscript. Let me write that somewhere else. For the hydrogens, there are 14. For nitrogens, there are 2. Oxygens, there are 2. The only exception is that you don't write a subscript if there's only one atom. So in the case of H2O, there's only one oxygen atom, but you don't write a 1 there. Are we good on chemical formulas? Again, you'll have practice for this. The final topic is talking about physical and chemical properties and changes. We'll go over what physical properties and physical changes are, and then I'll give you some examples of how you can classify them. We'll do the same for chemical ones, and then we should be done with Chapter 3. This is not everything for Chapter 3, and I'm going to stress that again. This is just hitting all the good spots. If you don't have time to take that full, luxurious shower, you better hit them armpits and hit the creases, okay? So that's what this is. We hitting the armpits, we hitting the creases. Wash your neck, it's hot. Wash your face, behind the knees. Y'all know what I'm talking about. You're grown, okay? That's what this is. You still need to watch the Chapter 3 lecture to get all of the nuance. This is just the quick version. Well, this ain't a sit-down restaurant. We driving through the cookout. Okay? Get your milkshake and your 8,000 pieces of food for $4, and then you sit down and enjoy a cheap meal. You may still want something else later because after an hour, that quesadilla is gone. Can we be real? Can we be honest with each other? So that's what this is. I am the quesadilla from Cookout. Not even the milkshake. Just getting the quesadilla. You still need to go get the full meal from the YouTube lecture. All right. I'm crazy. I apologize. This is actually who I am in real life. So, physical properties. I'm glad. Just being real. You can be a real person and still do science. I don't think we see that enough. You know, sometimes professors are stuffy and old, and it's just like, come on, y'all. You were people, right? Okay, enough of that. That's my diatribe for now. Physical properties versus physical change. Whenever we're talking about a property, we're talking about characteristics. If you were talking about the physical properties of a house, you would say how many square feet it has, how many bathrooms, what the countertop is made of. You know, in the kitchen, it's a marble countertop, whatever. Those are the physical properties, things that you can observe by eye. You don't have to do anything to destroy the house to figure out how many bathrooms there are. The equivalent with what we're talking about is things like color, density, melting or boiling point. All of those things are characteristics, things that you can determine just by observation or by heating or cooling something, but you're not changing the state of the substance and you're not changing the chemical composition. A physical change, what we're really talking about is a change in state, as in going from a solid to a liquid or a gas to a solid, something like that, or a change in shape. If you're cutting something down, making it smaller, adding something to it, making it bigger, you're not changing the composition. We're not doing any chemistry, but we're talking about something physically happening to a substance. So you're always going to see some kind of an action verb along with the physical change. So with that said, I want you to look at, we'll call this A and B, and label it as a physical property or a physical change. So I agree. The first one is a physical property. Good conductor, that's something that you can observe. You're not changing the composition of anything. You're not changing its state. You're just seeing, hey, can I get some electricity through here? Yes or no. Oxygen gas is compressed. That tells you that something is changing. There's an action happening. So that is a physical change. When you compress a gas, you're changing the volume. So go through the other two on your own time. And again, there will be plenty of practice. You need to be able to tell the difference between a physical property and a physical change. And then we're going to introduce chemical properties and chemical changes. So you need to be able to pick out all those four. Those are the four we're working with. Same way as the property versus the change with the physical properties and physical changes, it's a similar deal with chemical properties. The chemical property tells you about its chemical potential. What type of chemistry can it do? Does it react with a certain group of elements? Is it reactive in acid? Those are things that describe the types of chemistry that a substance can do. A chemical change is talking about a chemical reaction. And there's always going to be some kind of an action word with this. So something's burning, or there's a color change, or a gas is made. In the video, I talk about the evidence for chemical reaction. So that we're not going to go over it specifically here, but that will help you determine whether or not you're looking at a physical change a chemical change or a chemical property. With that said, we're going to again do just the first two. Tell me if it's a chemical property or a chemical change. So I agree with that. You see can combust, that tells you that we're talking about potential, the type of chemistry that gasoline can do. The opposite of that, we're looking at a burning candle. That's chemistry. Fire is chemistry. That's something that's actively happening. A reaction is going on. So it is a chemical change. That's all that I have for the Chapter 3 overview. There is much more to Chapter 3 than what we covered today. Maybe I won't say much more, but there's definitely more nuance than what we covered today. So please review the lecture and complete the Chapter 3 assignments. We're talking about the Mastering Chemistry homework and the quiz. Your exam 1 will open up at 8 a.m. tomorrow. So there's going to be a folder that it's labeled exam 1. You can't see it yet, it's not available to you. But in the course content, you will see a folder that says exam 1. Within that folder, you're going to see the exam itself. You're going to see the equation sheet, which is the same one that's already posted in the exam 1 review folder. You're going to want to print that out like we covered before. If you can't print it out, you don't have access to a printer, you can write it all down and use that. We're not going to be using the same exact equation sheet every time. It will change depending on what information you need. The last thing is you're going to see an assignment. I can't remember the exact name of it, but it's going to be something like work for exam 1. You need to upload your work. So when you're doing your chapter check-ins, like that kind of work, you need to write that out as you're taking your exam. And after you finish your exam in Respondus, open up Firefox or Google and upload your work as a PDF. Your grade will be negatively impacted if you do not upload your work. Your work is how I assess partial credit. And I make these exams by hand. So there's no test gen, there's no, you can't just look it up. I'm putting in the work, so I want you to put in the work too. And I see there's a hand raised. What's your question? Take a picture. Make sure that it's neat, but take a picture. You do not have to type it up. So as you're going through, make sure it's neat enough to take a good quality picture and upload that as a PDF. If I can't open it and I have to hunt you down, then I'm also going to take off points because that takes my time to say, hey, can you upload it? And then I wait for you to do it and then I can grade it. So make sure that you double check that it has been submitted and that it's in the right format. Don't make me do the work because you're going to pay for it. Other questions? I see another hand raised. Yep, exactly. Show me how you solve the problem. Are there any other questions for me about the exam, about anything? Because we have 8 minutes or so. If you don't have any questions, you don't want to stick around for any potential questions, you're free to go. Otherwise, ask your question. Oh, one more thing. Sorry. I'm just that fast. So Wednesday, I will have office hours again from 12:30 to 2:30. There were still several people who have not done the practice exam, which just tells me a little bit more about you and when office hours will work best for your schedule. Do that before you try to take the exam, because if you can't do the practice exam, you will not be able to take the actual real exams in the course. Don't email me on Friday night saying, Dr. Hefner, Ms. Hefner, I can't, it won't, my come through. No, I will be with my family. I'm going to have movie night with my husband and make some popcorn. I will not see that email until maybe Saturday or Sunday. So please try the practice exam and make sure that you can get it to work. It's Tuesday. You have until the end of Friday to take the exam. The practice test is posted on Blackboard. I posted it a while ago, but you should be able to click on the quizzes, tests, and exams link, and then you'll see it listed there. Respondus Lockdown Browser Practice Test or something like that. So please, please, please go. Yeah. Mhm. Yes. So you have flexibility to take the exam when you have the time. I would say a lot 2 hours, just because you want to make sure you get your technology right and everything. There's going to be a scientific calculator available to you through Respondus. So you can use your own calculator or you can use that one. It's a scientific calculator, but no cell phones. Any other questions? If you don't have any, yes, we can still talk. No, it is not open note. So you get the equation sheet, but that's it. So just as a look ahead, the final exam, I let you do a note card front and back. Um, but for the exams throughout the course, they are closed book, closed note exams.